we are going to continue the third example in the exercise 4.2. Here, example number 6. Integral -3 to 3 x cube upon 9 minus x square. Now here integral is equal to -3 to 3 x cube upon 9 minus x square. Okay, here. Now this integral we evaluate by using the direct method, that is in indefinite integral. We see the degree of polynomial in numerator is greater than the degree of polynomial in denominator, then first take the division and then solve the integral. But here the limit, it is a -3 to 3. Okay, by using the property, it is a simple method, -3 to 3. That means here we use the property minus a to a, last property, that is property number 8, and there first we check this function is even or odd. Even function means here it is f of x. If f of x is f of minus x is equal to f of x, then it is even function, and f of minus x is equal to minus f of x, then it is odd function. And in this property it is -3 to 3, that means minus a to a. There is two conditions. If f of x is even, then we write this integral is in the form of 2 into 0 to a f of x, and if the function is odd, then the directly value of this integral is a 0. Okay, now first we check this function is even or odd. Now here f of x, let it is a f of x is equal to x cube upon 9 minus x square. It is f of x. Now it is even or odd. First we check it is even or odd. Therefore we take this x replaced by the minus x. Therefore f of minus x is equal to minus x cube, x replaced by minus x, 9 minus x square, and then it is minus x cube upon 9 minus x square, and here this can be written, it is a minus f of x. This is minus, and here it is f of x, that means minus f of x. Therefore f of minus x is equal to minus f of x, that means the given function is odd function. Therefore f of x is an odd function. And we know that integral a to b, sorry, it is minus a to a, integral minus a to a f of x dx is equal to 0, because f of x is an odd function, and therefore we can directly write -3 to 3 x cube upon 9 minus x square dx is equal to 0. Without solving or without finding the integral of this function, we can directly write the answer, that is a 0, because this function is odd function and limit it is minus a to a. Okay, see carefully this. Now we take the second example. Example number 7. Integral minus pi by 2 to pi by 2. Again same, it is minus a to a, that means first we check the given function is even or odd. Log of 2 plus sin x upon 2 minus sin x dx. Again here the limits of the integral are in the form of minus a to a. Therefore, first we check this function is even or odd. Here, the integral minus pi by 2 to pi by 2 log of 2 plus sin x upon 2 minus sin x dx. Then it is a let f of x log of 2 plus sin x upon 2 minus sin x. Okay. For checking this function is even or odd, we replace x by minus x. Then f of minus x is equal to log of 2 plus sin of minus x upon 2 minus sin of minus x. Okay, x replaced by minus x, and we know that sin minus theta is equal to minus sin theta. Therefore, this can be written log of 2 minus sin x upon 2 plus sin x. 2, it is a minus sin x, and here it is a minus sin x. Therefore, it is a 2 plus sin x. And now see carefully, it is f of x or minus f of x. Here it is a 2 plus sin x upon 2 minus sin x, but f of x is 2 plus sin x upon 2 minus sin x. That means the reciprocal of this term. And here again we use the property of the logarithm. If we take the reciprocal, take the minus sign, and therefore this function, it is a minus log of 2 plus sin x upon 2 minus sin x. Here we take the reciprocal, plus becomes numerator and it is a minus becomes denominator, and it is a minus f of x. Okay. Here we use the property of logarithm. It is a log a is equal to minus log of 1 by a. When we take the reciprocal, it is a minus sign. And now f of minus x is equal to minus f of x. Again it is an odd function. Therefore, f of x is an odd function. And therefore, we know that integral minus a to a f of x dx, if it is odd, then it is 0. And then for integral minus pi by 2 to pi by 2 log of 2 plus sin x upon 2 minus sin x dx is equal to 0. Again here, without finding the integral, we can write directly answer by using the property of the definite integral. Okay. Now we see the next example. Example number 8. Integral minus pi by 4 to pi by 4 x plus pi by 4 upon 2 minus cos 2x dx. Okay. Again here the limits are minus pi by 4 to pi by 4, that means in the form of minus a to a. So first we check this function is even or odd. If it is even, then we find the integral, and if it is odd, then directly write it is 0. Now here integral minus pi by 4 to pi by 4 x plus pi by 4 upon 2 minus cos 2x dx. Okay, first we check this function here, f of x is equal to x plus pi by 4 upon 2 minus cos 2x. Okay, now for checking this is even or odd, we take f of minus x, and then it is minus x plus pi by 4 upon 2 minus cos of, it is minus x, that means minus 2x. Okay, again here this can be written minus x plus pi by 4 upon 2 minus cos 2x. Cos minus theta, it is cos theta. And now here compare these two. Okay, here f of minus x, see carefully, f of minus x is not equal to minus f of x or not equal to f of x. Okay, that means we can't say this is even or odd because it is not equal to f of x and not equal to minus f of x. Okay, here it is f of x, both are the not equal. If we take the minus, then both are the minus, that is minus x and minus pi by 2, minus pi by 4, but here only minus x and pi by 4 as it is a plus. That means we cannot say this function is a even or odd. Now how to find the integral of this function? Here it is a minus pi by 4 to pi by 4, that means minus a to a, and here it is a limit x plus pi by 4 upon 2 minus cos 2x. We can write, separate the denominator, we get the two functions and the two integrals, and now check these two integrals, it is a even or odd. Okay, now directly we cannot say it is a even or odd, this function. Okay, so this function can be written in the form of the two functions, addition of the two functions. Here integral minus pi by 4 to pi by 4. Okay, it is a x upon 2 minus cos 2x plus it is a pi by 4 upon 2 minus cos 2x dx. Now we separate the integrals. Minus pi by 4 to pi by 4. Okay, it is x upon 2 minus cos 2x dx plus minus pi by 4 to pi by 4. It is pi by 4 upon 2 minus cos 2x dx, and now we get the two integrals. Okay, here therefore this I we can write in the form of, it is I1 plus I2. Now first we solve this I1 and limit it is minus pi by 4 to pi by 4. Okay, now see carefully, for the I1 integral minus pi by 4 to pi by 4, here x upon 2 minus cos 2x dx. Here take the f of x. Okay, it is f of x, x upon 2 minus cos 2x. Then we find the f of minus x. Then it is minus x upon 2 minus cos of minus 2x, and we know that cos of minus 2x, it is a cos 2x, minus x upon 2 minus cos 2x, and it is minus f of x. F of minus x is equal to minus f of x. Therefore this function is an odd function. Therefore f of x is an odd function. And therefore I1 is equal to 0. the value of this integral, it is a 0. Now we solve this integral I2. Now for the I2, here we take the pi by 4 outside the integral, or take as it is. Here minus pi by 4 to the pi by 4, and here pi by 4 upon 2 minus cos 2x dx. Now here let this function we take, it is a g of x is equal to pi by 4 upon 2 minus cos 2x. Therefore g of minus x, it is a even or odd, we check, it is a pi by 4 upon 2 minus cos of minus 2x, and then it is pi by 4 upon 2 minus cos 2x, and it is a g of x. That means g of minus x is equal to g of x. Therefore it is a even function. Therefore g of x is an even function. And so the I2 can be written in the form of 2 into 0 to pi by 4 upon 2 minus cos 2x dx. See carefully, here we use the property when it is a even function, minus a to a f of x is equal to 2 into integral 0 to a f of x. When the f of x is even function, here we take the g of x, okay, here we take f of x, so here we take the another function, that is g of x. Then when it is even, minus a to a, we can write 2 into 0 to a. When it is even, minus pi by 4 to pi by 4, it is 2 into 0 to pi by 4. And now we can solve this integral. Here this can be written as, it is a pi by 4, take the outside, that means 2 into pi by 4, we can write it is a pi by 2. See carefully, 2 into pi by 4, 2 into pi by 4, it is a pi by 2, and here into 0 to pi by 4, 1 upon 2 minus cos 2x dx. And now this integral is in our type, that is 1 upon a plus b sin 2x. The method of solving such type of the integral, it is put tan x is equal to t, dx is equal to dt upon 1 plus t square, and cos 2x is equal to 1 minus t square upon 1 plus t square. Okay, now here put tan x is equal to t, therefore dx is equal to dt upon 1 plus t square, and cos 2x is equal to 1 minus t square upon 1 plus t square. It is a method for the solving such type of the integral, but it is definite integral, and here we use the substitution, so change the limit. When x is equal to 0, 0 to pi by 4, t is also 0, because x is equal to 0, then it is a tan 0, and tan 0 it is 0. And when x is equal to pi by 4, t is equal to 1, x is equal to pi by 4, it is a pi by 4, therefore tan pi by 4, it is 1. Now limit 0 to pi by 4, and our new limit, it is a 0 to 1. Therefore I2 is equal to, it is a pi by 2 into integral 0 to 1 dx, it is dt upon 1 plus t square, and whole to the upon 2 minus 1 minus t square upon 1 plus t square. Now by solving this, here 1 plus t square into 2, therefore 2 minus 2t, sorry, it is plus, here 2 plus 2t square, 2 plus 2t square minus 1, and again it is a plus t square. So here we get pi by 2 into integral 0 to 1 dt upon 1 plus t square whole to the upon 2 plus 2t square minus 1 and plus t square upon 1 plus t square. Now here upon 1 plus t square get cancelled. Here 2t square and t square, it is a 3t square minus, sorry, it is 3t square plus 1. It is a 1 upon quadratic function, and now 1 upon quadratic function by using the completing square method, but here it is only 2 terms. Okay? We can directly in the form of the special integral. Okay, see carefully this. Okay, our integral is I1 plus I2. I1 is a 0. Now we can solve I2. Okay, here see carefully this, write down this, we can erase it. Okay, remember this, I1 is equal to 0. Okay, see carefully this. Now we solve this integral. Now I2 is equal to pi by 2 into integral 0 to 1 upon 3t square plus 1 dt. See carefully. It is 1 plus t square get cancelled. It is a dt, and here 3t square and it is 2 minus 1, it is a plus 1. Now this 3 take the outside, then it is pi by 6. Okay, it is 2 and this 3. Okay, you can write in the next step 0 to 1 upon t square plus 1 by 3 dt, and this 1 by 3 we can write 1 by under root 3 square, and it is 1 upon x square plus a square. It is a pi by 6 into 1 by a tan inverse x by a, and here limit 0 to 1. Here root 3, it is a root 3 pi upon 6, and here tan inverse of under root 3t and limit 0 to 1. Here root 3 get 1. Okay, here upper limit minus lower limit. Now here it is under root 3 pi upon 6 tan inverse of root 3, tan inverse of root 3 minus tan inverse of 0, and then the last calculation, it is under root 3 pi upon 6 into here tan inverse of root 3, it is a pi by 3, tan inverse of root 3, it is a pi by 3, that is tan inverse of root 3, it is 60, it is pi by 3, and it is a 0. And now this 3 and this 3 get cancelled, we get pi square upon under root 3 into 6 or 6 under root 3, 6 under root 3. Okay, this root 3, and here 3 means root 3 into root 3, 1 root 3 get cancelled. It is a value of I2, and therefore I1, sorry, it is I is equal to I1 plus I2, and I1 it is a 0, therefore 0 plus pi square upon 6 under root 3, and then last answer of this question, it is pi square upon 6 under root 3. See carefully this. Okay, check all the calculations. Next example, example number 9. Here example number 9 we have already. Here example number 9, see carefully, it is minus pi by 4 to pi by 4 x cube into sine to the power 4x dx. Okay, this example we have already discussed in our lecture number, I think 11, when we take the proof of the property minus a to a. In this lecture, this example we have already done. It is odd function and the value of the integral, it is a 0. Now we take the next example. Example number 10, integral 0 to 1 log x plus 1 upon x square plus 1 dx. Here again it is a special substitution. It is a x square plus 1 and it is a log of x plus 1, okay, upon x square plus 1. Here we put x is equal to tan theta. Okay, see carefully. Integral 0 to 1 log of x plus 1 upon x square plus 1 dx. Now here put x is equal to tan theta, okay, because here tan square theta plus 1 and it is a sec square theta. Therefore theta is equal to tan inverse of x. Okay, now x is equal to tan theta, therefore dx is equal to derivative of tan theta, it is a sec square theta d theta. Now here it is a definite integral and we use the substitution, so change the limit. When x is equal to 0, theta is equal to, when x is equal to 0, it is a tan inverse of 0, then theta is equal to 0. And when x is equal to 1, theta is equal to, it is a tan inverse of 1 and tan inverse of 1, it is a pi by 4. Okay. Now when the variable it is a x, it is a limit 0 to 1. Now integral becomes in the form of theta. When variable is theta, limit is 0 to pi by 4. And therefore integral 0 to pi by 4 log of tan theta plus 1 upon tan square theta plus 1 and it is dx is sec square theta d theta. Okay. Then integral 0 to pi by 4 log of tan theta plus 1 or 1 plus tan theta upon, it is a sec square theta into sec square theta d theta. Now sec square theta get cancelled. We get the integral 0 to pi by 4 log of 1 plus tan theta d theta. Okay. Now we evaluate this integral log of 1 plus tan theta d theta. Okay. Now to evaluate this integral we use the property. Here it is a 0 to pi by 4. So here we use the property 0 to a f of x dx. Okay. Here it is the integral. It is equation number 1. Now here use integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay. Here in this example there is a variable is theta, so we can write here x replaced by theta. Now this integral we get integral 0 to pi by 4 log of 1 plus tan pi by 4 minus theta d theta. Okay. Here theta replaced by a minus theta. Okay. Now here we use tan pi by 4 minus theta, that means here we use the tan a minus b. Therefore integral 0 to pi by 4 log of 1 plus tan A minus tan B upon 1 plus tan A into tan B. It is a formula for the tan A minus B. Okay, and now here it is a tan pi by 4, tan pi by 4. Put the value of tan pi by 4, that is 1. Then integral 0 to pi by 4 log of 1 plus 1 minus tan theta upon 1 plus tan pi by 4, it is 1. Here it is 1 plus tan pi by 4 into tan theta, that is 1 into tan theta, tan theta. It is d theta. Now take the addition of these terms. 0 to pi by 4 log of addition 1 into this term 1 plus tan theta plus 1 minus tan theta upon 1 plus tan theta d theta. Then integral 0 to pi by 4, see carefully, it is a log of tan theta minus tan theta get cancelled. Here 1 plus 1, it is a 2 upon 1 plus tan theta d theta. And now here log of 2 upon 1 plus tan theta, here we use the property of the logarithm. Integral 0 to pi by 4 log 2 minus log of 1 plus tan theta, here we use the property of the logarithm. Now separate the integrals. 0 to pi by 4 log 2 d theta minus integral 0 to pi by 4 log of 1 plus tan theta d theta. Now here this integral we get after using the property, and the method is adding 1 and this integral. But here see carefully, it is a repeat here, so replace this by I, and then I is equal to, here log 2 constant, we can take the outside the integral, pi by 4 d theta minus I, see carefully this, okay, and then this I becomes here, so we can write 2I log 2 constant, and here integral of d theta, it is a theta, and limit 0 to pi by 4, okay, and here see carefully, it is 2I is equal to log 2 into theta and limit 0 to pi by 4, therefore upper limit minus lower limit, it is a pi by 4, so we can write here in the box, okay, here 2I is equal to log 2 into pi by 4 minus 0, pi by 4 minus 0, and therefore I is equal to, here 2, it is pi by 8 into log 2, here it is the last answer. I is equal to pi by 8 into log 2. See carefully, first here we use the substitution, it is a x is equal to tan theta, okay, for the simplification x is equal to tan theta, because 1 plus tan square theta, it is sec square theta, okay, see carefully. Now here this example also asks in the form of this, see carefully. Zero to pi by 4 log of 1 plus tan theta, 1 plus tan x dx, okay. This example can also ask in the form of this, here 0 to pi by 4 log of 1 plus tan x, 0 to pi by 4 log of 1 plus tan theta, here इथून पुढचा विचारू शकतो, ठीक आहे, आणि बोर्ड एक्झाम मध्ये याच्या आधी विचारलेला आहे, हियर इथून पुढचा, म्हणजे टेक्स्ट बुक मध्ये जरी असा एक्झाम्पल असला तरी एक्झाम मध्ये असं विचारतील, इथून पुढचा म्हणजे याचा आन्सर काय, पाय बाय 8 लॉग 2, सेम प्रोसिजर, फक्त थीटाच्या जागेवर काय येणार एक्स, आणि त्याच्यानुसार मग आन्सर लिहा. पुस्तकात थोडा मोठा दिला आहे, सबस्टिट्यूशन करा, सबस्टिट्यूशन केल्याच्या नंतर मग तुम्हाला हे फॉर्म येईल आणि नंतर याला सॉल्व करणार बाय युजिंग द प्रॉपर्टी. एक्झाममध्ये डायरेक्ट हेच विचारतील, म्हणजे या टाईपमध्ये क्वेश्चन, आणि याच्या आधी एकदा विचारलेला आहे, त्याच्यामुळे केअरफुली पहा.